Hello everyone, my name is Matt Griffin and I'd like to welcome you today. I am Percona's Director of Product Management. We will begin in just a moment with the webinar. I'd like to start with a bit of house cleaning. First, please raise your hand using the hand icon located on the GoToWebinar control panel, just to let me know that you can hear me okay. I'll look for hands raising. Great, see some hands raising. Okay, y'all can hear me, excellent. So next, during the webinar, everyone's going to be on mute. If you have any questions, though, during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. Those that we aren't able to address will be answered in a follow-up blog post on the Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours. So I'd like to thank everyone for attending today's webinar, Performance Monitoring and Troubleshooting of Percona XtraDB Cluster, presented by a special guest, Johan Andersson, the Severalnines CTO, and Percona consultant, Peter Boros. So let's begin. Johan, if you'll advance to the next slide, please. So clustered MySQL environments, such as Percona XtraDB Cluster, have some great advantages, but they typically involve more effort and resources to administer than standalone systems. A global view of all nodes is required in order to understand performance and the sources of bottlenecks. In a cluster, there is no centralized node, and each node can have a different view of the cluster. These and other challenges make it difficult to track down sources of issues. So ClusterControl is a cluster management tool created by Severalnines that can monitor Percona XtraDB Cluster and address these challenges. The software provides DBAs with the right metrics and tools such as graphs, dashboards, and alerts to manage, monitor, and optimize applications during development and production. So let's review what we're going to talk about today on the next slide. Johan, could you advance to the next slide, please? Great. Johan from Severalnines will share some information about Severalnines, the background. He'll talk about ClusterControl, give you an overview of the software, and then talk about some of the core features of the product. And then Peter Boros from Percona will give a demonstration of the software, and we'll finish the webinar today with a wrap-up and Q&A. So now I'd like to turn the floor over to Johan to tell us about Severalnines and ClusterControl. Johan?
Thank you very much, Matt. So my name is Johan Andersson, and I work at Severalnines. And I just want to give you first a little bit of introduction to us, and then we'll go into ClusterControl more. So we founded ourselves in 2011, and we are the founding people were a group of ex-MySQL Sun and Oracle staff. We have all quite extensive experience in working at MySQL, and especially working towards telecom customers there and helping them to build and architect the telecom switches, such as HLRs and stuff like that. Basically systems that are not allowed to fail. And we have our HQ in Sweden and in Stockholm, and our products are focused on cluster automation and management. Right now we have quite a few products that we're supporting with our tool, and we are then talking about MySQL, Percona, MariaDB, MongoDB, TokuMX. And to this date we have in excess of 7,000 deployed clusters running. Okay, so some of our customers that we have are, for example, Orange, Bing Identity, ABG, Mail and Guardian, Technicolor. This slide is showing some of the paying customers we have, but we also have a lot of other users that are using our product completely for free. So ClusterControl, our product, what is that? Well, to put it short, it's a product that helps you to do deployment, monitoring, and management and scaling of a cluster. So the deployment that we have helps you to get going very fast and get up with a production cluster, complete with the Power Cluster management software to make the underlying cluster presentable and work quite smooth with backups and stuff like that. And then we have a monitoring part that is fetching and showing data on the screen, statistics, and all kinds of stats monitoring and stats collection, basically. And then we have a management part which is involving everything from addition to nodes to backups and also management of the HA proxy, for example. Then we have the scaling thing, which then is of course adding nodes again. So deploy and monitoring features that we have are for free, and that's something that everyone can use. But if you would like to use the more sophisticated management features and scaling features that we have, well, then that's a paid feature and only available for our subscription customers. So why do we do this? Well, there are studies that shows that the cost of actually maintaining and keeping the database up and running is 4 times the actual cost of the database itself. It's a quite substantial cost, and that money could perhaps be spent on other things. And we are thinking that our tool, that we will demo later on here, will show you that it's can save you some of the save you from some of the day-to-day tasks that you would normally have to do, and also then allowing you to work more on the core focus of your business, such as optimizing the schema, making sure the queries are working fine, that the application servers are responding fast, etc., etc. So there is a lack of cluster management tools. There is plenty of monitoring solutions out there. That's for sure no lack of them. But most of these tools are for single nodes. There is no management involved in them. And what we want to do with our cluster control tool is, first of all, we want to add monitoring to the, we of course have monitoring, but we also want to enforce that and strengthen that by having cluster management. And instead of looking at the cluster as single or individual nodes, we actually want to view them as a cluster with the possibility to drill down into individual servers and down to the operating system level to track down potential issues. Of course, there are a few companies that have built their own stuff. It's Google, Facebook, etc. But it's very, often their solutions are quite geared towards their own environment. And in this sense, we also have a lot of companies that are building their own homegrown scripts, for example. But the problem with homegrown scripts is that the guy that wrote them may quit. He might be he might be sick, or that there are new versions coming out of for example, the MySQL software. The scripts then need to be updated and kept up to date, and that takes a lot of time. Then I also think what we are quite alone with here with cluster control is that we have a polyglot interface. This means that you, from one single application, can look at both SQL and NoSQL databases from the same interface. So we'll talk about a little bit short here now about cluster control, and to give a little overview of what it is. So again, we have the provisioning of databases, and this is what you can do in a couple of minutes. You will actually have a cluster up and running. You can also choose yourself where you want to run this cluster. Do you want to run it on premise or in the cloud, or wherever? It's completely up to you. We don't want to restrict you there at all. The management part includes automated failover, node automatic recovery, assistance with upgrades, backup scheduling, one-click scaling, and all these things, and some more things to make your everyday job a little bit easier. And we can also manage, multiple clusters from one single interface. When it comes to our monitoring part, we have down to a second resolution of the statistics collected. Unfortunately now, I must say that the UI is not able to show 1 second resolution yet. We're working on that, but you can get down to about 5 to 6 seconds resolution time on the UI, on the front-end side. But anyways, we're saving, of course, real-time and historical information about what's happening on your system. And this is one good feature that we have is actually that you can go back in time and check, for example, what happened between 0700 in the morning and 0800 in the morning yesterday. What happened with the different, for example, DB status parameters? Were there any of them that were suddenly starting to flush or something like that that was causing a sudden performance drop? Those are the things that you can get help with answering, together with our query monitor that is using the slow query log. So you are and you're able then to set the granularity on how much queries you want to be able to capture. But you will see you can get queries that are executing on your cluster, and you can also get a histogram where you see actually when particular queries have been running. We also have health checks to help you or to assist you when you have, if you're running out of buffers, connections, etc. Then thread cache size, table cache, etc. Things like that. You will get a warning if you are passing over some thresholds. Then we have email alarms and notifications, and it's also possible actually here to, if you're not happy with our health checks, you can write your own custom expressions. The custom expressions allows you to enter, basically any MySQL status variable and to calculate your own ratios and stuff like that. Set up thresholds when you want to have alerts and get graphs on it as well. We also have a Nagios integration plugin, which means that you can feed Nagios with the cluster state and different alarms that are being raised inside the cluster. This slide shows you a little high-level architecture of cluster control, which is the greenish part of this slide. We have at the top end, we have the self-service front end, which is the web UI in the current format, and the web UI is called the ClusterControl UI. And it talks to a REST API to fetch and receive data from ClusterControl, which is the middle two green blocks here, basically. And the ClusterControl then makes the automation and controlling of a number of different database clusters that you can have underneath it. We have connectivity to Galera, MongoDB, TokuMX, MySQL cluster, for instance. And for each of them, we give the same kind of user experience. For example, with configuration, provisioning, scaling, the ability to pay backups, schedule backups, performing upgrades, monitoring, these kind of things. It's all the same for all the databases that are managed by ClusterControl. And one cool thing here is, what I think, is that you can actually have from one process then the ability to manage several of these clusters at once, right? So from one process you can have a configuration file that is governing a Galera cluster, and then another file governing your Galera QA cluster, for example, and another one for describing your MongoDB cluster, and you will see it all in the same UI, Then the hardware that we support, as long as we're running on a Linux-based platform, then we're happy. So we have customers running on Amazon, Rackspace, and also on-premise is quite common here. And OpenStack and Eucalyptus, of course, as well. We also have a bunch of configurators. The configurators are web-based, and that allows you to go in and knock up a configuration for a cluster. When you have entered certain parameters, for example, how many CPU cores you have, IP addresses, where you want to have your data directories, some few core properties, then a configuration file is generated together with actually that is wrapped inside a deployment package. This deployment package that you get is something that you can take to one server, and then you unpack it there, and it will install the cluster that you described in the configurator. It's a very easy way, convenient way to get up and running with a new environment in 15 minutes, depending on bandwidth, etc., to download the necessary software, of course. But when you're done, you're up and running with a UI that Peter Boros soon will demo, and complete with the cluster management, cluster control software. We have two different flavors when it comes to deploying architecture, to deploying cluster control. The first one is then an agentless version, and then you also have an agentful mode. In the agentless mode, you just have one cluster control node. It's just one server. From this server, you are then the controller is then executing MySQL commands on 3306 towards the managed cluster. And in this case, I'm showing a couple of Galera nodes. Management then is done on port 22 or SSH port. So these ports are, of course, configurable. And the controller will pull operating system stats, etc., MySQL stats from the managed nodes, and do calculations and aggregates, etc., on the collected metrics. And then, of course, the CCUI will present the information. If you want, you can also then run with agents. It's very similar. Again, you have the controller is collecting a lot of stats. The only difference here really is the CC agent, the cluster control agent, is responsible for fetching operating system stats, and that's otherwise done from the controller itself. So whether you use agents or agentless installation, it doesn't matter. The features are the same, so it's no difference in that. It's just more a taste thing, I guess, what you would like to do. Then, of course, if you want to, what happens if the controller node fails? Well, you can have a standby controller node set up as well. So this is typically quite good if you have, a multi-data center setup, for example. You have data center A and B. Data center A goes down. You're completely blind. Well, what happens in data center B? Well, then you can start up the standby cluster control node there. There is a manual switch you have to do right now to toggle a switch on the standby node, but it's fairly easy to activate the standby node. So that's completely possible to set up like this as well. Then I want to show you a couple of features and what it kind of looks like within the user environment. And here I'm showing our custom expressions, and what you see here is expressions that are defined on different servers. You can go in and edit them, or if you click on one of the expressions, you will actually see the number of connections that are. You will actually see a graph below detailing out plotting the expression, the result of the expression. And you have warning critical levels. You can go in and just define a new expression if you want, if you should be active or not, if you should send notifications if something goes wrong. If you want to, if you're worried about like false positives, so to say, well, you can have you can set the threshold breaches. So you set a level. You know, this thing must happen, you know, X number of times before we actually raise an alarm. And then you can set the normal warning and critical levels, and then you also have you get information if the expression has been parsed all right, then that's the last execution error. And you can also actually pinpoint on which nodes you want to run this expression on. So you have fine-grained control on that. If you want to set a particular threshold on one node, for example. Then we have backups, and from the UI you can easily schedule backups. You can schedule MySQL dumps. You can schedule extra backup of full and incremental, and you can then choose if you want to store this on the node or on the controller. Then you also have to upload backup to AWS S3 Glacier. So if you want to store it on external storage, that's perfectly possible to do. Moreover, the backups, we divide them up into backup sets, and the backup set consists of a full backup and 0 more incremental backups. And then when you want to restore a particular backup, you actually restore one of these backup sets, and then we have a command line tool to help you through the restoration process. And then you will restore one backup set at a time. Now you can also exclude increments, for example. So the classic example there is if you have had you drop the table, and then just after you drop the table, you start an incremental backup, but you would like to restore to the incremental before you drop table, and then that's completely possible to do. Next up, we have add and remove nodes. You have a configuration template in the UI that you can go in and edit. For example, if you want to add, that you want to have binary logging on, log slave updates, etc. parameters, you can go in and define that in the template. And this template will then be used when you provision or add the new node. You have two different options here as well, that you can either when we add the node, we will provision the software for you. So if you are a Percona user and use Percona XtraDB 5.6 something, then we will install Percona XtraDB Cluster 5.6 on that node. But if you are already managing and maintaining a pre-installed software images, you can say that as well, and we will not try to install anything on the node. It's the software that you have that rules. And what we will do in the adding phase is that we will install the MySQL database. We will make sure grants are all right, so that the CMON cluster control process can monitor and manage the newly added node. And then when everything is fine, we will start the MySQL instance, and the MySQL instance will then perform an SST, and then it will be part of the cluster. So it's easy to add nodes, and removing them is even simpler actually. You just have to click on a minus button. Then we have HA proxy and keep alive D that we can also install. So HA proxy, if you want to install that, you can select a couple of MySQL servers that you want to include in the load balancing set. And then you select the host where you want to install the load balancer on, and then you can give it a name. You can also limit the number of backend connections, which is quite good to avoid connection flooding problems on your MySQL servers, rendering them useless, basically. You can also set the proxy port, which it should listen on. Then you have the option to build it from source or install the package, the Linux distribution is HA proxy, the HA proxy that comes with the Linux distribution. But some distributions does not have HA proxy, and then you can install it by building it from source. In which case we will download the latest stable version of HA proxy, and then it will be compiled and installed on the node. And the same thing happens with Keep Alive. And you can also install Galera arbitrators and remove Galera arbitrators from your cluster very easily. Finally, before handing over here to Peter, I'm going to talk a little bit about about our recovery procedures. We have two different flavors of recovery, basically. It's node recovery and cluster recovery. Node recovery is what it sounds like. When a node fails, you want to recover it, and it will be automatically recovered. And you will get an alarm notification saying, of course, first of all, that the node has disconnected. And then you will get a notification saying, now we're trying to start recovery, and then if recovery was successful or not. And if it wasn't successful, then you might have a problem. Because, I mean, recovery can fail, but we're also collecting log files from the MySQL server. So, it's pretty easy from the UI interface to go in and look at the different log files to figure out, is the problem why this node cannot be automatically recovered? Is it due to disk space? Is it due to other other things, such as disk corruption, or whatever it might be? Or is it that the extra backup failed on the donor, or it was not successfully prepared on the joiner? All these kind of things can be then answered quite easily. But normally the node recovery will recover the node automatically, and you will have progress basically messages saying when it was successful. Then you have automatic cluster recovery, and that requires that all nodes are reachable. This is because we want to determine the most advanced Galera node, the one which has the most data. Because the one that has the most data will become, the new primary, and then we start up the other nodes, and the other nodes will then be synced from that primary. So it's very important that we're able to nail the most advanced node. And if we cannot nail it, we will not perform automatic recovery. You will get an alarm saying that automatic cluster recovery is unsafe. And then you will have to try to make all nodes reachable, or you will have to contact, for example, Percona support to help you with further guidance. So then you can enable and also disable this feature in the CMON.SNF file. So thank you very much. I am done for me, and I will hand over to Peter Boros for the demo.
Thank you very much, Johan. Do you see my screen?
Yes.
Okay. So, in this demonstration, I will show you the agentless setup. And why I chose this is that probably the most frequent question I get regarding cluster control is how can it integrate with our infrastructure, with our existing infrastructure. Many people are using Puppet or Chef or Ansible or whatever infrastructure management tools, even CF Engine, to manage their clusters. And in this setup I will show you today, I have 3 nodes which are database servers. These are PXE1, 2, and 3. And as you can see, this is just a cluster which is running right now. So this is PXE1, 2, 3. And I have an application server. The application server runs HA proxy, which can connect the application to the cluster. And in our case, the application is sysbench in a wrapper. And sysbench will connect to a port which will distribute the connections evenly across the 3 nodes. And we are using a transaction rate limit of 10. So we will do roughly 10 sysbench transactions on average in this benchmark. Why the wrapper is needed is because most well-behaving applications are reconnecting on an error or something, and sysbench is not such a well-behaving application, but it's almost well-behaving application. It can tolerate some level of errors, but not everything. But it kind of makes sense, because if you are doing benchmarks, if you have lots of errors, you probably want to know about that, because it kind of invalidates your benchmarks. But now we are only using it as a workload simulator. So here we go. Started. So we have a cluster with application running, which brings us to our 5th node, which I called CC. And on this node, we will install the CMon itself and the ClusterControl UI. CMon will be the daemon which monitors the cluster, and the UI will be which we were using for managing it, and which you already seen on Johan's screenshot. So let's start by installing the CMon controller. I downloaded this in advance because, although I think that wget progress bars are very impressive, I think that I have better stuff to show. It has a single configuration file, which is cmon.cnf, and it uses a MySQL server locally. So this IP is actually the node CC's IP. So CC will have a MySQL server running on it, in which it will store metadata. And the MySQL password is CMon. The user will be CMon as well. You have to specify your operating system user for SSH. You have to specify the operating system. And basically, you can configure your cluster pretty simply. So I tell where are my nodes, right? At the top, I tell that the cluster type is Galera. And also I tell where is MySQL, how do I do data collection. I'm doing 10-second level data connection because all of this is running on my workstation, and I still want to make the video work as well. So let's put this configuration to its final place. This is done, and what we have to do is create the database for CMon. And I cheated a bit because I created the user in advance. So next task we have to do this deployment is to load the database schema to MySQL and to load the initial data to MySQL. When that's done, we can start CMon. Okay, it's running. So our next task, so Simon is running, it means that the cluster is being monitored. So, and we can get data from Simon either by querying its database or via REST API, but that's not too user-friendly. So let's install the UI with this script. Similarly, I'm not showing the wget. It detects an existing MySQL server. Yes, I want to use that. It downloads the latest release. Do I want to do a yum update? Yeah, why not? Let's do a yum update as well. And the installation is finished. So I go to a browser and I visit cc/install. You have some checks here to make sure all the prerequisites are in place. And for the purpose of this demonstration, the only thing I want to modify is the login email. I put my email address there, and I leave the password as admin. Okay, the password Simon and admin are not really a good security practice, so if you are not doing demonstrations like this, I recommend against them. So yes, I would like to register my cluster now automatically. Yes, this should be the cluster control. It detects the API token and the URL of Simon API. So I register my cluster, and I will have my cluster up and running. The controller is up, and the 3 masters are up. And if I check the overview, I see that the overview graph is being updated. If we take a quick look at Sysbench, we are doing on average 10 transactions a second, which consists of, for example, in this case, 140 reads and 40 writes. So a transaction is built from multiple reads and multiple writes. We are doing this benchmark, doing this rate-limited benchmark on 16 threads. So the graphs are being updated, and I immediately got some insight about what my cluster is doing. Right? This is a global view of all the cluster, but if I click Show Servers, I can check the servers individually. And I will, for example, I will see that load is distributed evenly. There you go. And let's check what does it want to tell us. It successfully imported our configuration, so that's kind of good. Okay, so cluster control took over the management of the cluster, which is great, right? So what is the first thing you are curious about any kind of cluster management solution? Of course, failure. So if let's say we crash this machine, this is a VM running on my workstation, so I see that there is a kernel panic and the machine is gone. And if we check Sysbench, if I scroll up for a while, you can see that we had 0 transactions, and the reason for that is that the node has to reach suspect I mode, which has a default limit of 5 seconds, before it is thrown out of the cluster. Because for these 5 seconds, we will wait for that to acknowledge the writes, but it doesn't. And since the transaction contains writes, they pile up a bit. See that they are queued up. We have a queue length of 37, and it catches up in the first second after my cluster with two nodes becomes available. So how is this visible within cluster control? At the top of this page, you will see that node 3 is disconnected, and we also see this red X instead of the green tick. So the node is down. And in the meantime, I restarted the node in the background, and Simon could SSH it. And it says node recovery detected, giving Galera a chance first. In the systems, I didn't configure MySQL to start automatically, but ClusterControl will recover it, so I'm not doing anything right now, apart from talking to you. And node recovery is in progress right now. Probably the machine is booting. Let's see what it does. I'm curious. Okay, so MySQL is starting up. Right, and whoops, it's gone. And soon it will. If we take the graphs, we can see the drop here in the TPS levels, which was caused by the node. And if we want to go down, that in the logs we see the timestamp that we have a new event, which is node recovery, which tells us that the node was actually down. So we can reference data to events and be able to tell easily what happened with that node. I would like to show you some features which need a subscription, and Johan provided me a demo license, which I just put here. And as a reward for being with us so far, you can see the license in this video, and you have like almost 10 days or so, 9 days, to try it out yourself without too much of a hassle. I mean the features which require license. So adding a license is as easy as this. And if I refresh the then I will see that I have a valid license. Why? No, it's not done.
Peter, that's actually a UI issue in this version.
So let's configure the monitor and set up gathering queries. Like every 30 seconds, I want to get all the queries. So I set long query time to 0, and it doesn't matter. Since long query time is 0, it doesn't matter if I'm logging the queries using indexes. And because of the nature of the sysbench workload, I am firing hundreds of queries each second. So sooner or later, which means that somewhat later than seconds, they will show up in the top query section of the query monitor. And we can check that, the cluster load with the comment counters, but we have as well. For example, here there's a tabular monitoring stuff, which shows the nodes state, receive they issued flow control or something like that. And we have graphs here of this at the hardware level. So this rate limited sysbench takes up 10% of CPU on all of my nodes. In a pretty unique fashion. We have disk stats and network statistics, which are shown pretty similarly. Okay, go back to top queries, and by this time we have something here, and we can see that sysbench transactions are fairly uniform in terms of size, or sysbench queries, because we see the same all over and over again. If you click on one, you will see the non-parameterized version of the query, so you can run explain. Actually, it runs explain for you as well. So it's really easy to work with. I don't like interfaces when it only shows the one with the optional parameters, because then I have to figure out some real parameter to put there. So from here we can collect the queries and the sysbench workload just continues to run. We see it has a pretty constant. This cluster is pretty healthy. ClusterControl says that as well. Also, you can configure alerts. So if ClusterControl is not only capable of graphing these, but it is capable of alerting these, so you can alert. And I don't want to leave you with the impression that this is the only graph we can have here. We create some custom dashboards, the WSREP custom dashboard. A metric I want to put here is the size of the local receive queue, just for that. And that's it. Tab will appear here with the custom graph. Click on the new tab. And there we go with the new custom graph. Note that not all SQS variables were there, but it's actually configurable. That what do you want to retention policy is configurable as well on the collection. And if you check it, our cluster is not performing too well right now. We have done throughput. Let's check our application log, let's say. Oh, yes, we have zero throughput. So what happened, right? Sysbench failed, the wrapper restarted it, and it can't even start it. And now it can, now it seems to recover, right? So cluster load had a serious drop, then we had a serious uptick because the traffic suddenly started in. And now, if you check the numbers on the right-hand side, we have our regular load. And so what happened? If only we had a way to find it out, right? Luckily, we enabled the query monitor to collect. So let's see if somebody ran something nasty. And indeed, this is the case. Somebody ran a big transaction, a big write, which took 1.5 minutes. Somebody copied some table to SB test big 2. Even the name sounds scary. Let's check what kind of table is this. Okay, so it must be, yeah, so it makes sense that copying 2 million records takes a while. And why I showed this issue to you is because long-running transactions is a very common root cause of performance, what I see in our consulting practice, because it can block right-set replication, because when it enters the queue, when it gets applied on the remote nodes, it blocks the queue because the queue has to wait for this transaction to be applied, although all the other transactions are probably applied already if they are shorter. And while this transaction is applied, the node can't do more transactions because the certification process wasn't done for this transaction. It didn't check if the new transaction is conflicting with this large transaction. So it has to wait. If I'm right about this, we will see this in our dashboard called bottlenecks, that the local receive queue of the nodes went up. And what was the originating node? Probably the node which had the lowest local receive queue. And you can see that it was no. So somebody executed that long-running transaction. Oh, it clicks too fast. Sorry about that. So somebody executed that long-running transaction on node 2, and now I, as the DBA, can go and have some talk with them. This was me checking how big the table was. So this is really, really configurable and really nice way to have some kind of insight to what is happening in the database. So you today is how can you install ClusterControl to manage your cluster in agentless fashion, which means that ClusterControl won't touch your setup, it won't configure anything for you. You can configure your own cluster, and ClusterControl will give you all the monitors and all the drill down analysis capabilities. And I showed how ClusterControl handles things. The first was a node failure, and the second was how can we detect that issue was a long-running transaction. Thank you for your attention, and back to you, Matt.
Thanks, Peter. Really appreciate it. Johan, I'm going to switch the slides to you. And some of you have mentioned some audio problems that are occurring. We apologize. We think it's related to the downside of having such rich graphs in ClusterControl. And so I've checked, and if you want more information on these types of demonstration videos of ClusterControl, you can find them on Severalnines' website and under the resources area. As you might have seen, Peter was using a version of ClusterControl called Percona XtraDB Cluster. There are actually 3 choices that you have available for ClusterControl. One choice is the Community Edition. It's a free download from Severalnines' website. Another choice is the Enterprise Edition that Johan mentioned in his part of the webinar. You can purchase it from Severalnines, and for a comparison of features, you can find that on Severalnines' website. And then finally is the version that Peter was using, the Percona XtraDB Cluster. This software is included as part of your subscription to a Percona support agreement for Percona XtraDB Cluster, MySQL Cluster, or MySQL Galera support. It's the software, but also the Percona support team will provide assistance with the configuration and administration of Percona Cluster Control, and we'll help you get up and running and help you make the most of the new management and monitoring tools for your high availability solution of choice. With that, we've got some great questions coming in. We probably have time for a couple. And as a reminder, we will have a follow-up blog post with answers to additional questions, and everyone will get a copy of this webinar. It will be made available within 48 hours. So with that, let's get to the questions. One question was about the installation of cluster control. And this user's databases don't have internet connectivity for the installation phase. He knows it would be possible for a workaround, but is there any kind of solutions or instructions to cover this scenario of installing cluster control without connectivity? Peter or Johan?
I will need to come back on that. I'm not sure we have any readily available instructions, but we do have in our configurators, for example, a possibility to run them in a non in an internetless mode, so to say.
Okay.
That requires you then that you will download software and manually put them on the node first.
Okay. Johan, you mentioned in your section about Nagios support. Is there a Cacti integration as well?
No, not at the moment.
Okay. In a deployment with the cluster control agent, does the agent keep OS stats during a connection outage with the controller? And if so, does that mean if there is a data loss, that there is a data loss in an agentless deployment if the controller cannot reach an agent for a while?
So the agents, they will not actually keep any data. So they're pretty dumb. They're just reading up stats periodically and then feeding them to the controller. Does it answer the question?
Sorry, can you repeat that one more time?
Does it answer the question? So the agent, when it is, if it cannot report in statistics, then it will not keep any statistics. It will just continue to read in new stats and send them to cluster control. So it's not keeping a backlog.
Okay. Okay. I think that's all the questions we have time to get to. Again, questions that we didn't get to, we will have a follow-up blog post and cover answers to those questions. One more final thing is, Johan, can you skip to the last slide of the presentation? Just as a reminder, the Percona Live MySQL Conference and Expo event is coming up at the beginning of April. We have some information here about advanced rates ending March 2nd, and then a special discount code. Use webinar SC to get a 10% off discount on the standard rates. And for more information, visit the URL listed on your screen. Thank you, Johan from Severalnines and Peter from Percona for presenting today, and thank you to everyone in the audience for joining. Again, any questions that we weren't able to get to, we'll post a follow-up blog post in the performance blog. And we look forward to seeing you joining us for the next webinar coming up, How to Avoid Common but Deadly MySQL Development Mistakes with Bill Carwin. Thank you, and hope you have a good day.